Okay, so hi everyone, and welcome to the final Student and Postdoc Association of the Engineering Biology Research Consortium panel/workshop of the calendar year. We will have more in the coming year, especially for those of you that are currently applying to graduate programs or getting started in one. We have some more things planned. So today we have a great panel/workshop that we've assembled related to getting started on a project or choosing a research topic, which we hope will be especially useful for those that have recently started in grad school or are starting soon. So we have a great panel assembled to help out with the presentation and also the Q&A session at the end. And so I'll let each of our panelists briefly introduce themselves from left to right here, starting with Aditya.
Hey everyone, I'm Aditya Kunjapur. I'm an assistant professor at the University of Delaware in their chemical and biomolecular engineering department, where I've been for about 6 years now. Yeah, I'll leave it at that.
Hi, everybody. I'm Sebastian. I'm currently a postdoc at the University of Washington, where I've been for the last 4 years. Before that, I was at Rice University. I did my PhD there. Yeah, happy to be here.
My name is Heidi. I'm a postdoc at Boston University. I've been here about 3 years. I work for Mary Dunlop and Will Khalil. I'm excited to be here.
Hi, everyone. My name is Ice. I graduated with a PhD from U of Washington in the molecular engineering program and just moved to the postdoc at MIT just a few months ago. So, and I'm in the process of exploring the research topic, which we're going to be talking about today.
Very topical for you guys. And hi, I'm Ross. I'm a postdoc at the University of British Columbia in Peter Zanstra's group, formerly a PhD student at MIT, where I did some bio work, and now I work on T cells. Okay, so let's go ahead and get into the workshop. So we're going to have a set of slides, hopefully not too long, and we're going to kind of pop in and go over several different aspects of choosing a research topic or planning your project that we hope will sort of give you different ways of thinking about this and will be helpful. And then at the end, there'll be time for Q&A where you can ask us questions about this or any other burning questions you have about choosing a project or evaluating the potential success of a project. Okay, so let's get into the first part of this, which is more focused on sort of a broader look at choosing research topics. And the first thing that I'd like to introduce is the sort of very high level look at innovation that DARPA, the US Department of Defense's sort of very applied research division, uses to think about projects. And so there's sort of two major axes that you can think about when you're doing research. One is sort of, are you sort of creating new fundamental knowledge, what we call fundamental research or basic research, and are you adding some practical, or are you trying to design for some practical use, what you might say is engineering. And what DARPA tries to go for in their particular brand of research is what they call use-inspired basic research, which has both practical use and also develops new fundamental knowledge. And when you're working in your own research projects, what you can think about in this framework is that you don't need to necessarily go for this, what to say, Pasteur's quadrant that has both of these angles, but you want to be thinking about am I going to do research that's going to create new understanding? Is my research going to create some new practical value or application or use that people can use? And you want to think about the value that you can generate on these two axes. And not all of the best research in the world falls into Pasteur's quadrant, but in general, I'd say if you're working in the engineering space, this tends to be sort of a goal for a lot of academic research. Another thing that you want to think about as you're approaching research is this concept of scales. And so Northwestern University has a lot of curricula that they're developing around this. But the work that we do in academia or even in industry sort of cuts across a lot of scales, going all the way down to, say, molecular engineering, all the way up to the societal consequences or applications that we're working on. And feasibly, when you're sort of designing projects or choosing what you want to work on, it might be difficult to work across the full spectrum of scales here. And likely you're going to be looking at a subset of this, but you want to keep the full scale of what you're working on in mind. And there's a lot of like particular cases where engineers didn't necessarily account for, let's say, some of the more like social side of the issues that they were working on, and that led to sort of poor design constraints. If you've heard of the problem with pulse oximeters and people that have darker melanin in their skin, this is an example of taking into account sort of the societal impact of your work. Basically, the outcome is that it didn't work as well for people that have more brown skin. And so that was a design flaw that wasn't accounting for sort of the societal side of the engineering equation. Okay, I'll hand it off to Ike's.
Yeah. So this is like another angle of like when we so I framed this kind of like topic as before we start past something like that, which is like something that I got into the videos that was provided by NIH when they try to work on like how to start a research topic. And you can see some keywords here. These are like some examples of the question that you can ask yourself or you can ask your team, like either at the different stage of like your research or like your planning of your like your research topic. So for example, before you do the actual research or before you start the research, like one thing that you wanna like tell yourself first is like, what is the area that you're gonna be working on? That's very important. Most of the time, if you are a PhD student or if you like already in the lab, you may have already choose that because it's something that is gonna be incorporated into the application that you filled in. And then after you join the team, something that I feel like very important when I listen to this kind of topic is that like sometimes you have to answer why you are the one or why is your team should be the people who explore this thing. It's not mainly because like whether you are good enough to do it or not, but it depends on a lot of like preparedness or the resources that you have. So like a very good example would be like how long does your team have in terms of like doing this kind of research, because that's another factors that will govern whether this topic will be good for you or not. And then after you start for a while, you may want to think like, is this the right time to do this kind of project? Because some project may be feasible, like maybe in the next 2 or 3 years, a lot of tools out there will be developed a lot to the point that like you may only take 2 years to conduct the research, while if you start right now, it may take you 10 years to get everything done by yourself. So that's another kind of like angle that you may want to talk with the team and figure it out before you get started. And the last one is like whenever you see the problem, it's a good thing to pause a bit and review whether what you're working on is like feasible. And after let's say that you're working on a 2-year project, after working for 6 months, you may want to take a step back and check if everything is going to go according to what you have planned. And if it changed from like a 2-year project into a 5-year project, that's a very good time point to pause and like reevaluate the goal that you're gonna push this project forward. Or maybe you wanna diverge or change the direction a little bit just to make sure that everything is going according to how you're planning. So again, like make sure that you know the aims, the feasibility, the knowledge gap, and the pitfalls of what you're working on.
Okay, great. So now to Heidi.
Yeah, kind of, I guess maybe following up on like most of these things are about like when you've like started the project and maybe once you're in your PhD program and maybe you're just trying to understand your own project a bit, because sometimes it's good for your training to join and support something else. This is something that we did based on something called the Heilmeyer Catechism, also from DARPA in Mary Dunlop's group. And basically we had 4 minutes to answer 3 questions. And the first one was trying to explain what you are trying to do, but without jargon. And then finding 3 papers that are like most closely related to the thing that you want to work on. And it was important that none of them be from the lab. And then the third thing to emphasize what was new about our approach, or what's the thing that we're doing that's like different from what's been published, or like how does the field benefit. And so I think the thing that's, I guess, the things that I like about this structurally and like why I think it works are that I think jargon can keep you from being sort of explicit. Like maybe you feel like because you've said the words CRISPR or synthetic biology, it like clearly is a science project. But sometimes what's important is to understand what your objective is in terms of like, is my goal to make this thing faster or cheaper or easier to use? Because these are different types of goals that would like lead to different types of work. And I think something I noticed when doing this is like often when I think about what the gaps of in knowledge are in the field, I'm actually describing my own knowledge gaps. Like I have some intuition about what the field knows, but it actually takes a bit of work in the literature to kind of understand what that gap actually is. And I liked this thing about not using papers from your own lab, because your own lab probably has a way of thinking about the problem and also what's important. And so if you can find other people writing about this stuff, then you have like people to connect to, and also you know what also like what other people care about, and like seeing how many papers there are might also give you a sense of like if it matters. And I think thinking a bit about like not only what's new, because I think it's very easy to be like, oh, well, no one has done this before, and that is why I'm doing it. But there's lots of things no one has done before because they're not good things to do. So I think a little bit kind of like we're saying is like thinking about what are the best possible outcomes, what do we get? And usually I think it's like a new knowledge or a new technique is hopefully the answer to that question. I think I'm going to hand it off to, yeah, next section.
Next section. Okay. So now a little bit more refined look at specific project planning. And there's some interesting things that we'd like to point out here. One is a nice Twitter thread that summarizes some information from a course at Stanford that talks about project design and selection. And I just took a couple of the images from this Twitter thread that I thought were interesting. So one is that you know, the amount of time that you spend planning your project is often pretty small compared to the total amount of time that you spend working on it. And people often rush to get into the project. But we would definitely encourage you to like take the time to do this sort of background reading and talk to a lot of people about your project plans, get into the lab, sort of start testing things out, because you know, you might be stuck on something for a long time, and if you spent a little bit more time reading, perhaps you would decide that now is not the right time, as I said, or that there is something else that you could do that would, you know, have a more refined way of answering a question about optimization, like Heidi said. So put in the time on the planning and it will pay off for your PhD or for your postdoc time. There's also a couple like axes you can think about in terms of project selection, if you have some different options. So how likely is it that it will succeed? So is it, you know, technically easy or difficult? Are you likely to publish it before maybe a competitor would publish similar work? And then the impact, if it is successful. So, you know, we all want to do very impactful work, of course. And so you can refine your project to think about what would be the greatest value I can bring, like Heidi said, in terms of developing new techniques that are broadly useful, identifying new knowledge that's broadly applicable to other people. And the third axis, I got ahead of myself slightly, is this sort of degree of competition. So there's a sort of a risk of scooping if you do something that's in a really hot field. Although if you're sort of the first or put out the best thing there, that could bring a lot of impact. And so these sort of axes can be helpful to think about, like, what is the right project for me, especially when you're kind of iterating through different options.
And something else I wanted to bring up is that it feels like it's very easy to understand the idea that like I should think about the risk or I should think about the knowledge gap. But when I reflect on my PhD, it took time to understand what those were kind of deeply. So I think something I want to emphasize is there's like various reasons this is hard. And they all just point to the fact that this process is like iterative and might take some time. And so I thought of like three things that I think are hard. So one is I think it's hard to express what a project is. When I review like research statements for NSF, JRFP, for example, like the number one piece of feedback I give everyone, and I've probably read like a dozen, is people tend to write what they're going to do, but not why they want to do it. So if at various points you can just ask, am I writing down what is I want to do instead of like why I want to do it? That might help you kind of really focus in on like, what is the thing that you actually want to do? I also think some of these things that, again, you want to think about, which is like, how hard is it going to be and how much knowledge I'm going to gain? It's like hard for you to assess. And ideally there's this like, again, like perfect quadrant you want to be in, which is like, it's very important knowledge and it's like not going to be hard to do. But there's probably only like a couple of projects that sit there. Whereas like there are many other projects that are like amazing ideas, but like very hard, or like, we can definitely do this, but like no one will care. So like maybe like be patient and give yourself time to like get like a set of ideas together. And pick through them. And yeah, I think it just takes time to understand various axes like how risky or how hard your project is, what the gaps are, and I think also your own interest, which is something interesting to think about. I remember I talked to a guy at a conference who was like, of course you want to work on what's interesting, but often like the thing that seems interesting to you is like something you don't understand well yet. That's why it's very shiny. So like also give yourself time to like be really rigorous about your interest as well. And then these are figures from a paper from Oriolan, and he's I think kind of famous for this idea that there's like a cloud in the middle of projects where you sort of like lose your way. But maybe something that's nice about academic research is maybe you have the time to like when you're trying to go from A to B to figure out that you like actually want to go to C. So I think related to that, kind of balancing like how much you need to plan. It's like projects like rarely proceed as planned. So it's maybe not necessary to like really perfect everything, and like it's like good to let things go. And I think there are also some like maybe hard trade-offs in terms of like getting things off the ground. Like how much do I really want to be independent and come up with this thing entirely on my own versus like bringing other people in, but then working on other people's ideas, I think is like one thing you can think about, and particularly at the start of your PhD. And the other one is like, again, this trade-off between how much time do I spend planning and thinking about ideas versus like being in the lab doing things. And there is some kind of balance in terms of like, you should ideally make time for both, but maybe you're not, don't ever like fully forget one. And then I think also like when to quit, because you're gonna like do experiments to like assess risk and de-risk things. And so I think that's also something that's sort of hard in the project planning phases, like to ask when do I move on, or like when do I like look for something else.
Great, thank you, Heidi. So next is Sebastian.
Yeah, as Heidi alluded a little bit, progress in projects is not necessarily linear, and sometimes things don't go your way. But in addition to that, even if things are going right, it's like kind of easy to lose yourself in the details of your own research and kind of lose sight of the big picture of why you're doing things or why you're going down a rabbit hole to solve a particular issue. So it is important to evaluate to like sit down, stop, pause, and evaluate your own progress from time to time. There's a formal mechanism to do this, which is it's called an individual development plan. Some labs implement that. Some universities require the PIs to implement that with their students. Some others don't. And it is always nice to get the buy-in from your PI to do something like this. But if you don't, it is still useful to try to do something like this every now and then to review your own goals and your own progress. So the way this works, this normally works, is that you sit down with your advisor with a document that has some questions about your own research every few months, normally every once a year. But in the case of my current lab, it's normally every like 4 or 6 months, something like that. And you talk about, it's really about a lot of broader goals in your own PhD career, your postdoc career. For the purposes of this presentation, we're just going to talk about research goals, but it's in general, most versions of this ask you also what fellowships are you going to apply in the near future? Are you looking for other jobs? Are you going through your class requirements, et cetera, et cetera? But for today, we're just going to focus on the type of questions that are related to research, which in this particular version that I'm mentioning from Stanford has this. Among their questions, some of these are some of them that are related to research. So, for example, always try to think back of what specific question your thesis or your work or your research is actually trying to answer. Again, it's very easy to get lost into some rabbit holes that sometimes you stop and think, why was I doing that again? What does that have to do with the broader context of my research? So sometimes it's useful to just pause for a little bit and ask if that's actually answering the question that you're working towards. How do you feel your project is progressing in general? Next. what are your near-term research goals? So what do you, if your IDP is every 6 months, what do you think you can feasibly achieve towards your research goals in the next 6 months for your next meeting? And it's also, as I mentioned, useful to look back to your previous IDP and describe what goals you were successful at achieving, but also what challenges you had in implementing the goals that you set out for yourself last time. And ask yourself things like, is it worth continuing towards this particular goal? And if it is, what things do I need to solve? Do I need help in certain things? Do I need to collaborate with some people, etc.?
All right, thank you, Sebastian. Okay, so we'll do a couple quick examples of things that some of us have done along the way within this realm of project design, and then we will open it up to our panel session. Okay, so the first sort of example is a de-identified version of a project ideas mapping that I did at the start of my postdoc, where I had some various ideas based on sort of things that were interesting to me, things that sort of built off of things that were going on in the lab, where I had already started working with a couple other postdocs on things. And so my PI had me sort of map out the things that I was interested in doing into this sort of risk to successful outcome and technical difficulty map. And then I color coded them based on the relative impact that I thought I had. And sort of what you want is, you know, the lowest possible technical risk and risk to outcome that has the highest impact. And so sort of like the one here in green is one that I, you know, continue to like a lot because it's sort of in that realm. But I also sort of connected these with arrows to help myself think through some of these were related ideas, or if I could do one, then it would open up something else. And so you can sort of like have multiple ideas, you can try to connect them together. There's a lot of ways to do this to help you visualize sort of like, you know, the likelihood of success and also like how impactful it will be, and maybe map out the steps you would take, because you can have like one project that leads to another project or multiple possible projects. And, you know, as you think about like longer term planning, you can try to see how they all connect together. And ice.
Yeah, so this is like something that would be a little bit specific. Like it's something that has already happened, which is from my PhD research. When I was a second year, when I just joined the lab after all the rotations, I just jump in and like see what there are several ongoing projects in the lab, and which one would be the top priority that you should be working on. Of course, like, you know, when you're doing the PhD research or postdoc research, that could be potential sort of projects you're going to work on. So evaluating each of the project on like which one would be your top priority would be a very good thing to do. So for example, one of the things that was in consideration was like developing a CRISPR gene activation for non-E. coli microbes. So this is very specific about, you know, you're going to do the CRISPR gene activation, you're going to work on the non-model organism, for example. So these are something that you have to understand what they are. And the background was that like the CRISPR activation like was developed in my PhD lab. So I know that there's some resource, there are some support from the team. Some of the theory has been discussed in the lab for a while. The key challenge in this case is that like in the non-model microbe, we don't really know a lot about. So this would be a potential risk that I have to make sure that if I were to do it, there's a challenge right there. And if it's something that no one in the lab has been working on yet, you may want to make sure that you know where to start, and you may want to know where to look for the help. But the impact and like the very, very important thing that I had at the time is to make sure that why would I be interested in this kind of work? So at the time, when I talk with a lot of people in the field, I see that people are very interested in the microbes that is not model, because in the industry, there's a lot of interest on the organism that is not E. coli, because E. coli, even though it's a model and it can help us with a lot of things in research, it's not like, you know, one to fit all, they can solve all the problem. So developing the tools for something that doesn't exist yet beyond E. coli would be very helpful for the field. And when I talk with my team, they help me get connected with the experts in in this kind of like non-model engineering system from other institutions. They can be like, if you know someone in your university where you can just, walk across the street and chat with them a bit, that's very helpful. But having like diverse people who can support you and you can talk to is very important as well. So this is like whether we have this kind of support or not. And personally, like it's also very important to evaluate for yourself, because you're the one who's gonna keep having to motivate yourself to work on it, right? So at the end of the day, I know that like if I were to work on the bioproduction, I really want to do it because I want to leverage my chemistry background and I want to learn more about the molecular biology angle of the research. That's why this project is going to fit. And I choose this one to be my top priority during my second year. And the other thing is like, I want to see how long do I have to like explore this project before I pause and reevaluate whether it's going to be done. And I think like, if we're lucky, it may take 2 years. And that's when I feel like this is doable and I'm going to shoot for it. So, this is just a one example. It's explicit, it's already done, and it really takes 2 years. And I do have a lot of support afterward. There's a lot of new projects that coming out of like this expedition that we work on. So when you work on your own project, I would suggest, like ask yourself a few questions, use some of the guidelines that we talk about today, and that would be a very cool, like stepping stone when you develop your own project. So the last thing that we're gonna talk on today is that like a lot of resources were available. And like what we were talking today is not something we just like built from scratch. There are a lot of resources out there in the field, even beyond engineering biology, that could be helpful for all of us. So let's make sure to explore more, listen to a lot of like suggestion out there, and there'll be a lot of discussion that could help you evaluate that could be faster or what could be improved in terms of the project defining in your case. I think that's it that we have, right, Bronze?
Yeah, so that's it for the slideshow here. And let me just stop sharing real quick so we can get into our Q&A part. And I'll put all those links into the chat briefly so that everyone has access to them if you didn't grab the QR codes. So before I do that, just quickly, like we'll have a couple of questions that we just asked to our panel to follow up on the presentation, and then we'll open it up to the audience. So just quickly, before I ask any specific questions, are there any points that anyone wants to bring up to follow up on anything from the slideshow? If you think of it later, that's okay. Okay. Sounds like we don't have anything specific. Good. Okay, so I'd like to start with Aditya, sorry, pronouncing it wrong. So Aditya has been on the side of reviewing applications before, and wanted to talk a little bit about what he sees from sort of the side of reviewing projects, for funding, but the perspective that brings. So go ahead and take it away, Aditya.
All right. Well, that was really great. I enjoyed those slides a lot. I think they captured a lot of what I would say. So I'm just going to kind of try to be succinct. I think two themes that came up were impact and feasibility in different ways. Impact is maybe a little bit easier for someone at the stage of undergraduate to graduate student, like somebody just joining a lab, to maybe gauge based on your own interests and what you think might be useful. But some questions I would say that you could try to ask your PI who you're considering, because maybe I'm thinking that the choice of project also relates to the choice of lab, trying to imagine someone going through both of those processes. I think your advisors are almost certainly going to have a reason why they think the project would be useful. You may want to ask if either them or graduate students in that lab, if there's an opportunity or an element to be creative, which relates a little bit to what some of the other panelists spoke about in terms of being new or different, avoiding competition and lowering the scoop risk. But I think you know, having an element that's creative or new are not necessarily the same thing, though they correlate. And either of them combined with the potential to be useful, not necessarily like the thing, you know, ending in something that's useful. But I think when I was a young graduate student, when I viewed the basic sciences, because I came from an engineering background, it wasn't clear to me why certain people were developing or studying some of the model systems that they were. And over time, I came to appreciate that there's like a lot of potential there to be useful. So you just have to articulate that or have your advisor articulate that. In the feasibility section, you know, I would break that down into, again, like ICE commented on YU. So some likelihood of success that comes from your lab having the right expertise or having key collaborators like already picked out. I would definitely ask about that. There's like a fine balance of how much preliminary data you might want to see as like a student coming into a project, because you don't want an area to be so mature or have older graduate students about to publish that it, you know, seems really exciting, but then becomes incremental by the time you publish. But at the same time, you definitely want to gauge risk and difficulty. And I liked a lot of the charts that were shown. I think it's just really hard to figure out how difficult a project is going to be before you've started. And maybe even for your advisor. This reminds me of something that George Church, my postdoctoral advisor, had to say, which is, you know, we like to work on projects that are perceived to be really difficult and would be to someone else, but we have like something, you know, like a secret sauce or a method in our lab that will probably get us there faster, or you know, in a way that others can't as easily access. And so that definitely relates to some of the other elements of competition and scoop risk. I liked that what was also brought up is like how long the project might take. I mean, some PIs, you know, occasionally myself included, have like a grand vision for a problem that we want to solve in like 10 years. But realistically, what you want is an attractive endpoint in, you know, 3 to 5 years. 3, because if you see it, if your PI thinks it's going to be solved in 3 years, it'll probably take 5. And then very related to that, which is something you can definitely ask your PI about when you're considering a project, is this combination of pitfalls and alternative approaches that I think ICE pulled from the NIH kind of considerations, as well as I think what Heidi spoke about in terms of pivoting and how the paths are never really linear. You would want to ask about all the things that could go wrong that like the PI has a plan as like a plan B or plan C. They're sort of contingency plan approaches. But also in the process, you could ask just or get a feel for their general comfort with pivoting. Because in my experience, a lot of those projects change. Sometimes the goals change, not just how you get there. And the most acrimonious situations that I feel like I saw when I was a grad student or postdoc were people who were you know, with their PI, there was a major disagreement about whether or not that project would work and when to like fail fast or try something else. And so that was a little bit of what I had thought about speaking about, but then a lot of that got inspired by what I just heard over the last few minutes. So hopefully that helps.
Yeah, thank you, Aditya. So I guess the last question for each of us before we open it up to the audience, and if you are in the audience, feel free to drop something into the chat and then we can pull it up, or you can raise your hand once we're done with this round and ask yourself. So is sort of how you got started in the lab, and this has sort of come up in bits and pieces, but I think it'd be good to hear sort of from us that have gone through this maybe twice now, for since a lot of us have been postdocs as well, sort of what your approach was. And I guess we can start with, well, ICE, you talked about it a little bit, so maybe can you talk about how you're approaching it in your postdoc?
Yeah, I would love to, because I'm doing it right now. So one thing that I would like to mention about getting started is like some labs really have a culture of pairing or partnering in the project. And if you have that kind of culture, it's going to be a very easy start. because you're not doing things alone. And sometimes you have the mentor, sometimes you have the colleague, sometimes you have friends to chat about like, hey, do you think that's possible? Do you think that's not possible? So in my opinion, when you start a new project, it would be good to not keep it with yourself until you get to the point that is not feasible anymore. At least like, when you're trying to see whether it's interesting or not, when you see that it's interesting, if we are working very close with your friend in the lab, try to chat with them and try to convince them that this is very interesting. Of course, like, working with the PI would be a very good, big step when you work on this. But like sometimes the PI doesn't work in the lab for a while and they don't really know how difficult it would be. So if you share that with your friends who has been doing the actual experiment or the actual work, sometimes you get a much better sense of timing or how long it would be. So I'll probably just end with that on kind of like make sure you're not working alone because like having a partner or having a friend to work on the project together is is way more fun. And that's what I'm taking on. Maybe others can jump in on about like wrapping up the project, hopping onto a new project, hopping onto existing project, something like that as well.
Continue. So I had two very different experiences in choosing projects in my PhD and my postdoc. In my PhD, I didn't like quite chose my project. I got put on a project immediately as soon as I got in there. It was a very extreme version of something Aditya mentioned, where my PI thought that it was going to take like 2-3 months to develop something that we wanted to develop, and then we're going to do a bunch of cool things with that tool, and just developing that ended up being my entire PhD. So that can happen. In my postdoc, things were a little more structured. We kind of had the advantage that we're in the middle of COVID when I was starting. So we had a lot of time to be on Zoom and to talk about things, and a little less pressure to go into the lab and do some work. So what my PI did at that time was to make everybody reevaluate their projects from scratch and just have a few weeks of lab meeting, which people just presented ideas from scratch. That was super cool, and that helped me propose some projects and get started into some projects. Now the project that I actually proposed and that I started working on failed pretty quickly, and I ended up working on something else. But that something else was also from that cycle of proposing projects. So and that ended up being my successful project. So it definitely helped, even if the thing that I immediately started working on didn't quite work out. So yeah, taking that time to just focus on reading and proposing ideas was definitely worth the time it took, definitely.
I was going to add some advice I heard in like a class I took early in grad school about like in a PhD, maybe you go through the project like life cycle 1.5 times, where you're sort of you join a project that's a bit in the middle because you need to learn some techniques, and you like finish, and then maybe you have enough information to like restart your own project, and then you can also carry it to completion, which is sort of like that idea. But it's similar, like Sebastian, I had the same experience. That I think what happened was when I arrived in the lab, there was some project that was supposed to take a year, and so I was like, we'll do that, and then we'll figure out what your thesis is. But that project ended up taking a very long time, and it became my thesis. And I think it's okay. I really loved the people I got to work with, and I really thought that like general area and like type of question was interesting. But it's funny how you kind of end up somewhere else, and I think that's okay, because I think there are things like getting skills and working with people that are creative and inspiring that are sort of more important than working on like precisely the thing that you thought you wanted to work on. And I think for me, something that's like hard, like this like question of when to quit, is I think the thing that I'm still trying to learn about. Because I think in my postdoc, I wanted to switch and try like a new model organism. So I was doing mammalian synthetic biology before, and now I work in yeast. And I wanted to like use yeast as a model of some mammalian processes, but I didn't understand enough about yeast until I was like maybe a year and a half in. And then I was like, oh, there's actually like a lot of reasons this like thing that I wanted to study is like not quite right in yeast maybe. And kind of wanting to like, it was cool because I got money to like pursue an independent question, but then I was the only one in the lab who was like, I'm just really excited about this thing. And so that also kind of made it harder when things started to not work as well. So I don't know, like I think I'm very much a fail slow person, which is like maybe I think there's like maybe some upsides to like being like I can stay pretty enthusiastic and like always come up with a new idea, but then sometimes it's like I think there could have been a transition earlier. But that's sort of been my experience.
Great, thanks everyone. So open it to questions now. And I see that Aditya already answered one in the chat. And so maybe I'll leave that there. But if you have something you want to ask, feel free to just open up your mic or type it into the chat. Okay. So how much preliminary data should we expect to start a research project? Just to check, do you mean like for you to generate to like be able to start it, or for there to exist for you to be willing to start it? I guess those are kind of similar. Any thoughts? Maybe I'm curious what Aditya would think about this.
Yeah, I'm happy to start on that one just because I think I brought up preliminary data, although someone else may have as well. You know, I've noticed in my experience, especially at Delaware, which has got a lot of synthetic biology activity, but isn't quite the same as like an MIT or some of the Bay Area programs in terms of where faculty might source their funding from. I found that in most schools, like Delaware, you know, typically if you have a project, it's because a proposal got funded. And maybe that's even true more often than I think at places like MIT. But typically for a proposal to be funded, there has to be some, it's like this balancing act of the professors proposing this topic have to actually demonstrate to other scientists that there's a little bit of capability to work on the project and some de-risked elements, or at least really good contingency plans to get around potential failures. And so that's why I think some projects you do have that already when they're offered to first-year graduate students or to postdocs. And so I find that I'm not asked about that very often by new members, but my lab is primarily 15 graduate students, and like the only postdocs are graduate students hanging out about to find their next real postdoc. But basically, I think there's an opportunity there to ask to maybe see what evidence, especially in a newer lab like mine. This might not be as much of an issue if you're like joining David Baker's lab and you want to know if protein, you know, neural networks can be used for protein design or labs like that. So yeah, that's sort of what I meant by preliminary data. But the how much is like, I mean, any, I think would make me feel a little bit safer than if the PI has moved into a new area. And I recognize that this is a struggle because as a PI, sometimes I want to move into new areas. But if you are in an area where the PI is not that much of an expert and they're new, and you might be the only one working on that topic, like maybe Heidi described, but you're a first-year graduate student, that to me, there's a lot of risk there. And it might mean that your PIs and older graduate students are less able to discern where the risk might be.
Yeah, to add on one thing to this, somebody brought up earlier like failing fast and this idea of or Heidi said, I guess, failing slow. So you can also think about like if it's a brand new project or something that you're thinking about branching off from an existing project or starting up completely new, like what preliminary data should you generate to like prove it wrong as quickly as possible? Like what is the critical thing? And this is like the fail fast idea. One thing that we were talking about, and I think it is worth mentioning here, is that there's a little bit of sort of like a potential for, you know, false negative and false positive as you get going on projects. So, you know, you might try to fail fast and make a killer experiment to literally kill a project to decide if you should do it or not. And it's possible that it will fail for reasons that, you know, you could have worked around, and then that project would have worked. And on the flip side, sometimes you get started on a project because you have some exciting preliminary data, and then you kind of hit a wall for a while. And I'd say the latter is much more common because, you know, like people have data, so they continue to pursue it, and then they hit a wall for a while. And so I don't know if there's like a perfect formula here, but, you know, for yourself, I guess, and for your own progress, it's good to have these sort of meetings to discuss with your PI, like, am I running into a wall here? Should I adapt? You know, should I change my goal? Like what Heidi brought up earlier, or, you know, is it worth trying to power through this because we're so convinced on what we're trying to do that, you know, maybe that we want to keep the goal the same, but we want to try alternate strategies. And, you know, so we decided that our fail fast strategy, we want to try to fail slower or something like that. So I think that this is sort of like a back and forth you can have with your PI, with other group members, try to get as much feedback from other people as possible when you run into any kind of wall. And that can help you to, like, you know, decide, am I changing my goal or am I changing my approach to the same goal?
Just to add a little bit even more nuance to fail fast. Sometimes failure is not easy to define. And maybe if you're interested in it's a high-risk project that you want to kill as soon as possible, maybe you should try to define failure in advance, because what can happen, what did happen a lot to me in my PhD was that I got frequently into the situation where I thought this is the last experiment, none of this is working. So if this one thing doesn't work, then I'll drop the project and do something else. And if it works, then that's cool. I'll continue, but at least I'll be like more enthusiastic about this project. And none of those happened. It like worked, but like barely, a little bit, like enough to be discouraging, but not enough to kill the project. And then I was like, oh damn, I'm gonna have to keep working on that. And to give it a little bit of a happy ending to this, that was actually my main project, the project that I got assigned on, that was like super frustrating for a long time until it like actually worked for good, and eventually graduated with that. So it's like a lot of nuance in like defining exactly what failure means. So it is as people have mentioned repeatedly today, it's not an easy problem to in general assess your own progress. So it is extra useful to try to talk to more senior people, to your advisors, and so on.
Yeah. Before we hop onto Kenyon, I want to add very short point about like the term that DOE really like to use, which is a goal no-go point. Sometimes you know apply that to your like benchmark or your data acquisition process. If you have some goal no-go point, that could help a lot. Whether like that's going to be like a clear path, or it's going to be something that you should stop right away because it's a no-go, something like that.
Kenyon, go ahead.
Yeah, I have a question about literature reviews. I think it's a common pattern to do a literature review at the beginning of a project. I didn't see anybody actually mention that kind of phase. And certainly if you're approaching a topic that's new to you, it's very much, you can like try to boil the ocean in terms of a literature review. So kind of where is the line? I understand, like, you know, we should always keep reading new literature about our subjects, but like, is there some guidance on how to decide that you kind of know enough and can start embarking on your first kind of experiments?
I wanna give a quick answer on that, on the process of literature review, which is like sometimes when you're trying to look for something and you cannot find it to get to be a starting point of your like process, it doesn't mean it exists, right? And a lot of times you find a great literature when you talk with the friends or people who have like similar interests, and that would be like, you know, one of the suggestions that I would tell everyone, that like, hey, it's a lot easier if you talk with people who may share some interest about some particular tools. Like, for example, if I want to work with non-model microbes and I don't know, and I can't find the tools to use in literature, I'll probably like, you know, look for someone who are trying to do something similar. Doesn't have to do the same goal with me, but they maybe use some similar organism. And that's like, I learned a lot from them, especially like something that was unpublished. like people opens up a lot when they talk about their failure, and some project that they killed, they talk about it with enthusiasm, and sometimes you can't find that during your like Google literature review.
Yeah, this might be later stage than what you're thinking, but something I think about is usually the problem or like the research project is like built on like 4 or 5 key facts. Like we don't know X, or like we predict that like this will be a problem or something. And I think if you can like try to find the precise papers that maybe state that problem, that's like maybe a good way to test like, is that actually kind of the way that the field works? And like maybe think about it like if I were going to write the introduction to the paper where I sort of, because usually there's like 3 or 4 paragraphs that are something about like why this model system, or like this is like a particular subproblem. And if you could find all those papers, I think that would be helpful. And I think this is something that Mary had us do again. I liked find the 3 most closely related papers. If you can define those, that'll also give you a sense of like what kind of field are these people in, like what like level or scale are they working at. The other thing I really like is connectedpapers.com, which is like pseudo free. But if you put in a paper you really love, it generates this graph, and then they're colored by, I forget, there's like a color and size for each node, but it tells you like how many times it's been cited and how old it is. And so I like that, because if I find something I like, then I'll just ask like, is there some paper that's been cited a bunch and seems foundational because it's old? And then what are the most closely related new things? Oh, thanks, Russ.
Any other questions? I think we do one more. Started a little bit late. Otherwise, I might add one more point to the thing about reading. When I was like starting up in my postdoc, where I think that my anecdote is most relevant, I like just finished my thesis defense, and then I needed to write a fellowship application within 2 weeks. And so without being there and with like little contact, I set up a couple of Zoom meetings to talk to people that were in my future lab, current lab, to kind of like ask, what were the problems that they're working on, where they're at with things, because they had a general idea from talking to the PI of like where things were going. And then I like read papers from the lab, papers in the space. And something I just want to point out is that often when you're new into an area, I would recommend to reread papers multiple times. So after you've like read those papers from your lab, and then you're going to read maybe some papers that they cite, you're going to read recent reviews and papers that they cite. And to each paper, you're going to read it more or less in detail. You can't exhaustively read every word that's written in every single paper, but you can try to get the key messages from them that you need. Go back to some of those papers that you read at the start, and you'll understand the context of what they're saying, and you'll get it more. So like the second time that I read sort of like the key paper from our lab, after I'd done all this other research, then I was like, oh, okay, now I don't just like get sort of what they did, because you can look at a paper and maybe understand the figures, right? But you can understand the knowledge gaps. And understanding those knowledge gaps, I think, ties back to sort of our presentation, where it's like the why. It's not just about like, I want to design X to do Y, which is, maybe like a good engineering objective, but like, what are the knowledge gaps? Like, what do we not know how to do as a field? And like, the more you read, the more you'll understand that. And you can come back to, the paper from your lab. You can ask questions to people in your lab, or your PI, to like try to resolve that better and better, which will allow you to define an objective or like a knowledge gap that you can try to address more precisely. Okay. So if you have any questions to follow up, feel free to email Ice and I. I think we had our emails on the email that went out, and we can forward it to anybody here in case it's more specifically for them. But otherwise, Ice, if you have a final thing to say, I'll let you say it, and then I will end.
Yeah. I just want to add to your final remark quickly that like a lot of time when you read your friend's paper, especially when they're still in the lab, ask them why they do that instead of like doing like, why are you doing A instead of B? That's when you learn a lot when you start a new lab, when you start in a new lab or in a new project. That's just that.
Cool. Okay, thanks everyone. This will be posted in the next couple weeks or so. So if you want to review or send it off to your friends, and I think that we can send along the slides as well to all the people that registered, or like a PDF of them so that you have it for reference. Cool. So thanks again, everyone. This was a presentation of the Engineering Biology Research Consortium Student and Postdoc Association. If you are currently a grad student or postdoc, you can actually join by going on to ebrc.org, I think, and looking up there. We have an application. It's very short. We do a lot of like workshops and panels, some targeted undergrads, some targeted to grad students and postdocs, or all of them like this one. So come check it out. We also do outreach activities, and we would love your participation or support in those if you are interested. So thanks again to all the panelists for joining, especially Aditya, who's a professor and very graciously gave us time to support us postdocs, us mere postdocs in this process.
Hey, thanks for having me, and you guys are doing a great service to the community. So thanks for having me.
Yeah. Okay, thanks everyone again. And
Thanks everyone.